Assalamu alaikum YouTubers, welcome back to SLK Tools. Here in this section, we'll be talking about steel's calculations just per pier, pile and a circular column when they have a spiral ties, alright? In the previous lecture, we have also done these guys, but in that lecture, we had just circular ties, alright? And here we are just passing with spirals, just like a spring. And that's will be really nice, I think. For example, let me show you how can you pass these guys in practical life. Just look at this picture. You can clearly see the combination of spirals with the main bars. Look at just this guys, these spring type reinforcement. These are called spirals. So I think we must have a few examples to understand these guys better. So here is an example, alright. I'll come straight into solutions. In the solutions, my approach will be just main bars first. Then I'll go ahead for these spirals. And per main bar weight, I just need the main bar's length, which is number of bars times the length of one bar. This is quite simple, alright. So the total main bar length will be number of bars. We are a number of bars. Just count these dots, alright, these black dots. These represents the main bars, and which are 23, alright. You can clearly see over here. Just look at the rate of 23 numbers. So I'll just put 23 over here times length of one bar. Just look at the length must be at height, and the height is over here given, or the length is given over here as 20 meter. So I must put 20 meter, alright. And remember, from the designer side, we are not informed to take extra length, alright, for hooks or overlays. And this is quite simple. So you must get the total length per main bars 460 meter, and this is really awesome. When I have the total length, then I can just really easily calculate its weight. Let me calculate the weight for main bars. W of bar must be d squared divided by 162.196, and this is really amazing formula for weight of round bar. Alright, just to know where this formula comes from, just watch a nice video in the same playlist called proof for formula just for weight calculation of steel bar. Alright, you can watch that later. Well, alright, this formula will give you a weight in kg per meter per round bar, alright, and just per mile steel bar. The proof is given in this playlist, alright. So when this is unit, I'll just multiply total length. This will give me overall weight per overall total steel length, alright. So the weight must be, what is D over here? D is just the diameter of bar in mm, alright. So the diameter of bar, just look at over here, this is 26, so 26 square divided by this guy times length is given over here, which is 460, we did a few minutes ago. So the weight must be, when you calculate this guy, you must get 4.167 times the length. The weight must be 1917.2 kg. Yes, but really I don't want the weight of main bars in kg. I want to calculate the weight of main bars just in tons. So to convert this guy into tons, you must divide this guy by 1000, because 1 ton equals 1000 kg, right? So you must get the weight equals 1.917 tons. Yes, I like it. So this was our first approach. My next approach is to calculate just spiral length and its weight. And of course this is quite simple. You can clearly see the spiral over here in this lug section. And of course this must look like in 3D, like this one. For spiral weight, we just need the spiral length. I'll just calculate the length of spiral. How can I calculate length of spiral? Of course, I can use Pythagoras theorem, which is c square plus p square square root times n. Here n represents number of pitches, c just represents just the circumference of a spiral bar, right? And the p just represents the pitch. Let me calculate n first, which is number of pitches, and this is quite simple. I'll just put this guy over here, which is h by p. Here h represents the height of spiral, which is just the total height of this column or length, right? And the p just represent the pitch. So plug in check in, you must get n equals h. Where is h? Of course, this is just the length. Over here you can see it is 20 meter, right? So 20 divided by 0.15, because the pitch is just 15 centimeter, it means 0.15 meter. You must get n equals 133.34, or I can say 134. Let me calculate c, which is circumference, right? And circumference, just look at over here. The spiral, just look in top or in section is a circle, right? And the circle circumference is always pi d or pi d or 2 pi r, right? It's quite simple. So I just need, let me just put over here, I'll call c just for circumference, which is pi times d. Now the d is little challenging over here. I'll just take the d just from the center of this spiral bar to the center of this side bar, right? It means I just need to subtract from 1, which is the total diameter of this column, or a pile, alright. So 1 negative 2 times concrete cover just for one side and another side, right? And it means I'll just subtract 2 times concrete cover. Now I just need the diameter from center to center of this bar. It means I just need to subtract 2 times half diameter, because one half diameter to one side and half diameter to another side. It means 2 times half diameter. So plug in, check in, mug in, second, and this is quite, I'll say pi times 1 negative 2 times concrete cover. Just look at over here, concrete cover is 5 centimeter, right? And 5 centimeter is just 0.05 meter, right? I can say 2 times 0.05 meter. Negative. And these two guys just cross each other, right? It means I have only diameter just for spiral. And the diameter of spiral is just 10 mm. It means it is 1 centimeter, right? And the 1 centimeter can be written as 0.01 meter. So I just subtract 0.01 meter, right? So when you calculate this portion, you must get 0.89 times pi, you must get 2.796, a circumference of the spiral bar. So all things is given in this formula. N is given, circumference over here, and the P is just pitch, which is 15 centimeter, right? I'll just plug these guys over here in this equation, which is just the square root of C, and the C is just over here, 2.796. So the square of 2.796 plus the pitch square, and the pitch is 15 centimeter. It means 0.15 square. Actually 0.15 meter is just 15 centimeter, right? Times n, and the n is given over here, which is 134, right? We did this guy a few minutes ago. So you must get the length of spiral bar equals 375.2 meter. But look at over here. From the designer side, we are informed to take 40 diameter per 30 meter length just per overlap. It means we need 1 overlap per 30 meter length of spiral, right? It means I just need to add, actually the length of spiral is not just 375.2. This is not complete yet, right? we just need to add all overlaps. Just one overlap per 30 meter. But how much overlap must be there? Let me calculate the overlaps first. The overlaps must be, it means the number of overlaps must be, look at over here, one overlap per 30 meter. So I'll just divide all this length by 30, right? Here just L represent the length of spiral bar. Just plug in, chug in, the length of spiral bar is given over here, and just divide this guy by 30, you must get this guy over here, 12.5. Let me just suppose this guy is 30, right? So it's 13, right? So I just need to add 13 overlaps with the length of spiral bar, right? Just look, the one overlap length is 40 diameter of bar. I'll just multiply this guy with 13 so I can get all length per 13 overlaps. So plug in, chug in, just per diameter of this bar you must get, the diameter of bar is just 10 mm. It means this is the diameter of the spiral bar, right? And 10 mm is just 1 centimeter, or you can say it's 0.01 meter, right? So 40 times 0.01 times 13. You must get the length of spiral bar, right? When you calculate these guys is 380.4 meter, and this was really amazing. So when I have the length of spiral bar, then I can just calculate its weight, and the weight must be calculated using a nice formula as I use it always, right? And the proof is given in this playlist too, right? You can also prove this formula. But this formula will give you answer in kg per meter, right? But I have 380.4 meter. It means I just multiply this guy with this formula, right? You must get the W of bar equals, what will be the diameter, right, over here? The diameter must be in mm. And the spiral bar diameter is just 10 mm, right? And 10 square divided by 162.196, right? Times this guy. You must get W when you calculate this portion, 0.616, times the length. You must get the W equals 234.53 kg. You can also convert this guy into tons by dividing this by 1000, because 1 ton equals 1000 kg. You must get weight equals 0.234 tons just per spiral bar. So our first approach was main bars, which is 1.917 tons. Our second approach was spiral bar, which is 0.234 tons. And this is how we can calculate steels just for pier, pile, round columns. Thank you for watching. See you next time, and